Hello everyone, in this lecture I am going to cover some of the fundamentals related to global positioning system. The global positioning system has revolutionized navigation and position location. It is now the primary means of navigation for most ships and aircraft and is widely used in surveying and many other applications. Navstar GPS, which is an abbreviation for Navigation System with Time and Ranging and Global Positioning System. On July 14, 1974, the very first Navstar satellite was launched. These first satellites were used for concept validation purposes or phase 1 of the project. They carried the first atomic clocks ever launched into space. On February 22, 1978, the first Block 1 satellites were launched. A total of 11 Block 1 satellites were launched between 1978 and 1985 on the Atlas Venture rocket. By the mid-1990s, the system was fully operational with 24 satellites. Now let's have a look at the components of the system. It consists of space segment, control segment, and user segment. The GPS space segment consists of 24 satellites in medium Earth orbit at a nominal altitude of 20,200 km with an orbital inclination of 55 degrees. The satellites are clustered in groups of 4 called constellations, with each constellation separated by 60 degrees in longitude. The orbital period is approximately one half of a sidereal day, or 11 hours 58 minutes. So the same satellites appear in the same position in the sky twice each day. The orbits of the 24 GPS satellites ensure that at any time, anywhere in the world, a GPS receiver can pick up signals from at least 4 satellites. The satellites weigh 1877 kg at launch and have a design lifetime of 10 years. In 2000, there were 30 GPS satellites in orbit, some of which were space. The GPS satellites have 4 atomic clocks, 3 nickel-cadmium batteries, 2 solar panels, which are used for battery charging, power generation of about 1136 watts, S-band antennas for satellite control, 12-element L-band antennas for user communication. Now let's go into details of control segment. The master control station and a series of subsidiary control stations around the globe continuously monitor all GPS satellites as they come into view and determine the orbit of each satellite. The master control station and other stations calculate ephemeris data for each satellite, atomic clock error, and numerous other parameters needed for the navigation message. There are 5 GPS monitor stations located in Hawaii, Colorado Springs, Ascension Island in the Atlantic Ocean, Diego Garcia in the Indian Ocean, and Kwajalein in the Pacific Ocean. The monitor stations have precise cesium time standards and take continuous measurements of range to all visible satellites. These measurements are performed every 1.5 seconds and used to provide updates for the navigation message. The user segment consists of GPS antennas and receiver or processors. They are used for finding position, velocity, precise timing, and are used commercially by aircrafts, ground vehicle ships, and intelligence. The position of a GPS receiver is found by trilateration, which is one of the simplest and most accurate methods of locating an unknown position. In trilateration, the distance of the unknown point from 3 known points is measured. The intersection of arcs corresponding to 3 distances defines the unknown point related to the known points. Since 3 measurements can be used to solve 3 equations to give the latitude, longitude, and elevation of the receiver. There are 2 types of triangulation, 2D and 3D. GPS uses 3D triangulation. 3D has the capability to tell altitude or height, while 2D doesn't have that capability. So we use the following formula for calculating distance. Velocity into time will give you distance. Radio waves travel at the speed of light, which is roughly 1,86,000 miles per second. So 1,86,000 miles per second into 0.06 seconds will give you 11,160 miles. Say you are 10 miles from satellite A. You are in a sphere with a radius 10 miles away from satellite A. If we are 15 miles from satellite B, then there is another sphere drawn, and the same for a third satellite and its sphere. At the common point of the satellite is your location. Let's have a look at GPS satellite grouping. There are three distinct groups and one subgroup of Navstar GPS satellites. Block 1 consists of 11 satellites were prototypes and just for testing purposes. Block 2 group satellites were first set of fully functional satellites with cesium atomic clocks, which can detect certain errors and provide alarms using coded messages, which can operate for about 3.5 days between receiving updates and corrections from control segment. Block 2A satellites are more intelligent and can go for 180 days between uploads. Block 2A satellites are similar to Block 2A satellites except having autonomous navigation capabilities. Now we'll see how to identify the GPS satellites. There are three identifying numbers. Navstar number, it identifies the specific satellite on board hardware. SV number, which is Space Vehicle Number, assigned in order of vehicle launch. PRN code number is a unique integer number used for encrypting the signal from satellite. Now let's have a look at GPS frequencies. The CA code is transmitted on the L1 frequency as a 1.023 MHz signal. The P code is transmitted on both the L1 and L2 frequencies as a 10.23 MHz signal. L3 is used by the Defense Support Program to signal detection of missile launches, nuclear detonations and other applications. L4 is used for additional correction to the part of the atmosphere that is ionized by solar radiation. L5 is used as a civilian safety of life signal. L1 1575.42 MHz. L2 frequency 1227.60 MHz. L3 frequency is 1381.05 MHz and the frequency of L4 is 1379.913 MHz and L5 frequency is 1176.45 MHz. Frequency L2C was launched in 2005. L2C is civilian GPS signal which is designed specifically to meet the commercial needs. It enables ionospheric connection, the technique that boosts accuracy. It delivers fast signal acquisition, enhanced reliability and greater operating range. It broadcasts at a higher effective power, making it easier to receive under trees and even outdoors. Satellite broadcasts two forms of clock information. The first is course or acquisition code, which is freely available to the public, while the restricted or precise code, that is P code, is reserved for military usage. The P code is similar code broadcast at 10.23 MHz, but it repeats only once a week. Now let's have a look at signal generation in a GPS satellite. The L1 frequency is 154 times the master clock frequency of 10.23 MHz. The CA code has a clock rate of 1.023 MHz and the C by A code sequence has 1023 bits, so the PN sequence lasts exactly 1 millisecond. The P code is transmitted using BPSK modulation at the L2 carrier frequency of 122.7.6 MHz and is also transmitted with BPSK modulation on the L1 carrier frequency in phase quadrature with the C by A code BPSK modulation. The figure shows the way in which the L1 and L2 signals are generated on board a GPS satellite. The coarse acquisition and pre-code transmissions from all GPS satellites are overlaid in the L1 and L2 frequency bands, making GPS a direct sequence spread spectrum system. The receiver separates signals from individual GPS satellites using knowledge of the unique C by A code that is allocated to each satellite. At most, 12 GPS satellites can be seen by receiver at any one time. So the coding gain in the spread spectrum receiver must be sufficient to overcome the interference caused by 11 unwanted signals while recovering the 12th wanted signal. The figure shows a simplified block diagram of a C by A code GPS receiver. The antenna is typically a circularly polarized patch antenna with an LNA mounted on the printed circuit board. A conventional superheterodyne receiver is used to generate an IF signal in a bandwidth of about 2 MHz, which is sampled using I and Q sampling techniques and processed digitally. The digital portion of the receiver includes a C by A code generator, a correlator, and a microprocessor that makes the timing measurements and calculates the receiver's position. Most GPS receivers make use of 12-channel IC chipset that can be purchased. Thank you everyone. Have a good day.